So now let's talk about parallel and perpendicular lines. Our goal here is to take everything we learned in our geometry class in high school, Euclidean geometry, and translate it to the coordinate plane. Let's look at two lines that are parallel, that is, that do not intersect. Say I have one here, and I have one here. What do I know about the slope of these lines? Well, if I move over 1 unit this way, I have to move up the slope, which we'll call M1 for the red line. If the slope of the blue line was any different, then this angle would be different, and eventually they would cross. So that means the slope of the blue line, we'll call it M2, has to be equal to the slope of the red line. So for parallel lines, the slopes have to be equal. So M1 will have to be equal to M2. What about if they're perpendicular? So if I have a line that looks like this and another line that looks like this, what do I know about the slopes? Well, if I move over 1 unit this way, then the red line will have slope M1. Whatever this distance is will be the slope. And for the same one, whatever I move down in this case will be the slope of this line. So that'll be M2. This will be M2, this part here. This is M1, this part here. Let's zoom in on these triangles for a bit. Now, this is a right triangle here because these two sides are parallel to the axes, and so this is also a right angle. This is also a right angle because these two lines are perpendicular. That means that this angle here and this angle here add up to 90 degrees. So they're complementary angles. But if you add all the angles in a triangle together, you get 180 degrees. So that means whatever this angle is here and this angle here have to add up to 90 degrees because the other 90 degrees is already used up. So that makes those two angles also complementary. Well, that means this angle will have to be the same as this angle over here. By the same reasoning, this angle here will have to be the same as this angle over here. So we have two similar triangles. The thing about similar triangles is the ratio of their sides is the same. That means if I take the side opposite the green angle in the red triangle, which is this length here, and divide it by the side opposite of the orange, which is this side here, I should get the same thing if I do the side opposite the green side here, which is this one, and divide it by the side opposite of the orange one, which is this one. So that gives that M1, if I divide that by the bottom side, I should get the same number if I divide 1 by the blue side. Now, is M2 a positive or negative number? Well, M2 is a negative number because the slope of the blue line is negative. If I'm dividing by the distance here is a positive number, which will be negative M2. Negative M2 is a positive number because M2 is a negative number, so a negative times a negative is a positive. So this gives our relationship between perpendicular lines. They're going to be the negative reciprocal of each other.